I guess we're about ready to go. I'd like to welcome everybody. Thank you very much for coming to our session. My name is Paul Fisher. I work for AlertLogic. We build security and compliance products for cloud environments. George Miranda is from Chef. He's joining us as a guest speaker at the session. Here's our information if you want to follow us, have conversations with us on Twitter or LinkedIn. And the session really today is about, talking about DevOps. We've talked a lot about that during the conference today. It's focusing on how do you apply security practice techniques to DevOps tools and techniques, bring those things together, and then really talk about where that needs to go in the sort of highly dynamic environments that exist today in AWS and everywhere else. So hopefully we'll have good things to talk about. I'm going to turn it over to George to cover the first part, and then we'll cover the details later. Thanks.
There we go. So hey everybody, I'm George. I work for Chef. I've been an infrastructure engineer for the last 15 years. Mostly in what's labeled as being on the operations side of the house, but really in reality kind of all over the map. I've worked for Chef for a couple of years, which means that I've gotten to interact with a lot of customers that are either just getting started with automation or are at several points along, I guess what you could describe as the maturity curve of starting to move fast in terms of delivering software. And so what we're going to do today is we're going to talk about how practices that get labeled as DevOps can improve your security posture. Which means that this talk is really aimed at two different groups of folks, I think. If you're a DevOps practitioner, this is a great session because we can start talking about ways to start moving the ball forward in terms of security, some prescriptive practices. But I think we're going to draw a lot of security-minded folks as well, folks typically on the security and risk management side of things. And so we may not always be on the same page about what DevOps is. So I'm going to start with kind of a high-level overview, and then we're going to talk about workflow implications, emergent patterns that we see, and how we can work in a more secure manner when our workflows resemble these patterns. So I like to summarize DevOps by saying that DevOps is a practitioner-led movement that is experience-based, and it's really just a culture of looking at the current state of IT, figuring out what things we can do better, whether that's technology or cultural, and just kind of focusing on improving the way that we work together as groups. So there's a lot of nuance to that, but that movement is also fundamentally rooted in the idea that what drives our businesses is being able to deliver software faster, safer, and more reliably directly into the hands of our users. And so this is kind of a good working definition to run with. And when we start going down this path, where we typically start is automation. And more importantly, we start with configuration management. So configuration management is not a procedural view of the world. It is not run this command, run that command, run the other, and then profit. Configuration management sort of takes a step back and looks at different ways that we can manage our infrastructure. So I have this quote up on the screen from Mark Burgess, creator of CF Engine, arguably the father of operating system configuration management. And Mark and a number of other people have an entire field of study devoted to looking at how we can manage distributed systems and efficient patterns that work at large scales. And at small scales, right, if we're managing tens of nodes or maybe the low hundreds of nodes, procedural views of the world work very well. But when we start sprawling the size of our infrastructure, especially in a cloud-enabled world, when we're managing hundreds or thousands or even tens of thousands of nodes and different API endpoints for services, the amount of force that we need to control that infrastructure can become very unsustainable and very unmanageable pretty quickly. Which usually at that scale leads us down the path of looking at configuration management. And so when we look at configuration management, what we start doing is we start describing the state of infrastructure that we want. Rather than a set of instructions that we should carry out, we start describing through code what should be configured, what we expect to have happen in our infrastructure. And so we start looking at the desired state of things that we want and start expressing those things in code. So configuration management frameworks allow us to write code that says what we should have happen, and then the configuration management framework makes it go. We take that code and we treat it like we do any other code base. We check it into source control, we version it, we manage the release of that whenever we've made a change. And so suddenly what this leads to is kind of this overlap of skills, right? We are now at this aha moment where DevOps has this cross-section of skills. We are applying software development lifecycle practices to the way that we manage our infrastructure. And this is the my peanut butter and your chocolate moment, right? This is great. How have we not been doing this sooner? I'm not going to belabor the point on DevOps. I think there's been a lot that's been written and said about it. What DevOps is not is it is not a tool. It is not something that a vendor can sell you, but it is a way of interacting with your environment, a way of approaching these types of patterns. But one of the things that is very common in the DevOps movement is a pattern that we've heard a lot about, even in the keynotes today, which is a pattern that most folks describe as immutable infrastructure. So one of the things that we know from working in Amazon is that it's typically much easier to replace a broken process with a new server or a new service rather than try to fix one that is broken in place. I hear a lot of different names for this. This is usually described as cattle, or sorry, as your servers are not pets, they're cattle. I hear this as the paper plate model of computing, right? If your paper plate is broken, just throw it away and get another one. Infrastructure is garbage, like take your pick of labels. But the idea is that you can just replace things rather than fixing them. And if you take this to its logical conclusion, what we end up with is a pattern for managing our infrastructure known as immutable infrastructure. And what we do in immutable infrastructure is basically divide our application infrastructure into two components, things that are data and things that are everything else. And for those things that are everything else, we never replace or we never make updates in place, right? We create a new versioned definition that says what is the state of the thing that we want, and then we launch it in parallel, right? Once that thing is in place, great, go ahead and destroy the old infrastructure. And so this is often referred to as blue-green deployments, different ways of managing. But when you start down this path, what you end up with is a tool chain that is pretty flexible and resilient, because what it does is it forces you to respond to infrastructure failure. Infrastructure fails for all sorts of reasons. We lose nodes, services are in half-baked, half-broken states. And what this does is it gives us a process to be able to fix those things very quickly, very efficiently, and deal with failure. Failure is built in the system. How do we know? Because we are forcing that failure all the time. We are dropping infrastructure and replacing it. And this type of process tends to work a lot better in stateless application stacks, and the reality of most of our application stacks is that we're not fully there, right? Most software is not built to handle that kind of fall in, fall out type scenario. But I think as an industry, we're getting there, and definitely as a practice, there are a couple of things that you can do to drive you towards a place where this type of model is achievable. When we start dealing with infrastructure as code, we take a configuration management framework and set it to converge our infrastructure on a regular interval. And what I mean by that is our configuration management frameworks will look at the state of the infrastructure that we want and make sure that that is the state that is applied. Configuration management frameworks are also idempotent, which means you can give them the same instruction set and they will result in the same thing all day long. So the initial provisioning of infrastructure might be a little bit expensive, right? We haven't installed software, gotten the latest version of our application there. But subsequent runs should be very quick, very inexpensive. If the state of the system that we found is not the state that we want, then we will go ahead and apply that state. If the state matches, great, we do nothing. And what happens when you start working in that manner is a pretty interesting thing. Suddenly, you now have a culture that eschews ad hoc changes. Any change must be in source control, must be checked in somewhere if it's going to persist. If you make a change outside of the bounds of that infrastructure code base that you've defined, your configuration management framework is going to undo that change. And if the configuration management framework doesn't undo that change, well, that server's probably not going to live very long anyway. So any changes that you made by hand are going to go away. And so we get to a place where out-of-band changes are going to be lost. And I think this is a very important aha moment for the security community. Because what it means is that there's this very sneaky thing that just happened. It means that in this new type of culture, whether your devs or your ops or anybody that's managing this IT infrastructure knows it or not, suddenly they're operating in this model where there is a big, giant compliance engine ensuring that we have an auditable trail of actions and that everything is captured, that the state of things that we want is actually the state that's there. So this is a very good opportunity because we get to a point where we're suddenly working in ways that security and risk management has wanted us to work for years, right? This is no longer a burdensome afterthought to make sure that you are in compliance. It is the default way of working and approaching your infrastructure. This is a great opportunity to become directly involved. And when you start going down this path, right, of trying to deliver software faster, safer, and more reliably to your users, we end up in the DevOps world talking about continuous delivery, continuous integration patterns. And there's a lot to this, but the takeaway from this slide is basically that any change that you make must be methodically rolled out and is usually tested several places along the way out to production. Right? We do regression tests, unit tests, functional tests. We automate the deployment of that into our integration environments, QA, staging, whatever that life cycle is, all the way out to production. And so the fact that we do so much testing for any change that is introduced, I think is a great opportunity for security and risk management to start inserting tests earlier into the process. When we look at test-driven infrastructure, this is a tried and true slide. I think we've seen this many different times. It is a lot easier and cheaper to find bugs quickly during your development phase and deal with them then as opposed to when they are live out in production. We typically see this graph in terms of responding to application bugs, but we should be talking about this graph in terms of fixing security issues, right? If there's something that needs to be remediated, let's find earlier places to look for it, test it, and in a model where we are testing changes and rolling them out methodically all the time, we have several opportunities to start getting involved early, right? Early detection is key. Find it, diagnose it, and fix it before it ever gets out into the hands of your users. And so what this type of culture enables is a place for us to stand back and look at our default security posture. And so I like to say, I'm not sure if you can really see the colors here, but that everything on the left-hand portion of this slide, you get for free when working in a CI/CD type workflow, and you use a configuration management framework behind it. Suddenly you get auditing and compliance, right? There is always a trail of changes that were made, and you know exactly what state your infrastructure is in. Disaster recovery, if you take that code base of your application infrastructure definitions along with any of the relevant data for your application, you can go ahead and apply that to compute resources and rebuild your entire infrastructure. How do we know? Because we do it all the time, every single time we roll out a change. And when you detect security vulnerabilities, right, if you get things that you could not have tested for, you get a heartbleed or a shell shock, right, you can go ahead, write a little bit of code that detects whether that needs to be remediated, test whether what you did actually fixed that issue, and then roll that out to hundreds or thousands of servers in minutes as opposed to hours or days or weeks. But there's also this whole other side of the equation that I don't think we talk enough about in the DevOps community, which is how we do continuous detection and protection, right? The exact ways that we should be provisioning and scaling our infrastructure, and how we get an end-to-end look at everything that we're managing. So I'm going to turn over the talk to Paul at this point so that he can talk about practices to ensure security in a fast-moving world.
Thank you, George. Here's my mic. There we go. Sorry. So what I'd like to cover is really to talk a little bit about challenges sort of that come up with security technologies. Talk a little bit about the AWS shared responsibility model where that all of the AWS services sort of take care of things, do a really good job of delivering on your security, auditability, compliance. But then on top of that, there's a bunch of things that you still need to do to pass your audits, to make sure you're secure, to make sure that you're building, deploying good infrastructure. After that, I want to talk about a couple of best practices that sort of leverage a bunch of the DevOps techniques that George introduced, and talk about how to get those done, how to get the most out of them from a security perspective. And then finally, what I really want to talk about at the end is sort of outline where we're going in terms of software-defined security. So I'll talk about some of the challenges I mentioned in the beginning and how we can see sort of products, our configuration management efforts, the overall DevOps efforts in our environments, how we can see those accelerating and matching security to sort of the velocity that we get with normal DevOps practices to just get code out, get features out, move the velocity faster. So this slide just sort of depicts shared responsibility models. You know, at the bottom, you see a bunch of the Amazon services building up to the left. Lots of that stuff is very well hardened, very well audited, and ready to go, basically, from a security perspective. But on the right, what you still have is you still have network attacks because you still have ports open for almost every application to the world. And through those vectors, there are still attacks. So at the network level, you still need to protect yourself. At the sort of system level, you need to do the right things. I mean, Amazon doesn't provide all the configuration on your servers for your applications. You need to do that. That's part of what you do with DevOps configuration management tools, but you need to do that in a way that is auditable, that delivers good security value. And on top of that, you need to then provide protection at your application level, which I think is probably the biggest open area because it's the least affected area by the efforts that Amazon makes. IDC basically, or 451, I'm sorry, basically indicates that security still is top of mind of all the things that worry people about coming into the cloud. We heard in the keynote that the promise of better security is drawing people, but I think that's a tide that's just starting to turn. I think what we have to do is look for ways to really enforce these best practices and get the most out of what we do in applying DevOps and security practice to deployments in AWS. There's really three big challenge areas, if you boil it all down, that you have to worry about. So at the network level, it's both in traditional infrastructure as well as AWS, there's network changes. They happen all the time. You do them for good reasons, but they don't necessarily get done with complete visibility to everybody. So you could make a network change that all of a sudden makes a database or something else visible when it wasn't before. Being able to know that those things happen is important. Host identity is the same sort of problem. What you have is you have instances that go up, that come down, you switched out versions, you take a whole any manner of approaches, and the identity that you think about logically as being this same system is really different. It could end up with different addresses, end up with different images. Ultimately, you need to find a way to see continuity across those things with security tools, technologies. Finally, auto-scaling environments, you don't have one or two of a certain type of system. You set it up to auto-scale, so you have hundreds of those systems. How do you start to deal with groups of systems from a security perspective so that you can manage that environment and you can make sure that you're not doing sort of extraordinary things that are weird application of traditional techniques, like, for example, vulnerability scanning all of your auto-scaled instances. They all come from one AMI. They don't have any different behavior. So there's a bunch of things that have to change to be able to get, and leverage good security practices in the sort of rapid moving cloud and DevOps models. At the most fundamental level, security practice is slow. You do scans every week if you do them quickly, or monthly, or quarterly because you're forced to. But the reality is that DevOps deployments in mature organizations are once a week, once a day, couple of tens of times a day. So if you take those sort of two models, overlap them, security tools techniques don't see one of 10, one of 100 sort of deployment configurations of your environment. So that has to change. It has to change quickly. And really, ultimately, the people doing InfoSec can't keep up. They're under a mountain of paperwork just because of the practices. Good. Ultimately, this quote from the Phoenix Project really sums it up. InfoSec professionals are trying, and really, ultimately, unless it changes significantly, you're not going to keep up. People will just shove you aside, the developers will rush ahead, and then the practices that really need to be there won't be available, and audit time comes around, vulnerabilities come around, and that's a bad conversation to end up having. So the next section I'm going to talk about really is what can we do today using security technologies, DevOps practices and tools to make things better. So at the most fundamental level, you should be able to prevent wholesale attack vectors by taking a fairly extreme view on immutable systems. And I'll talk about that in a minute. You can adopt a strategy of, as George talked about, blue-green upgrades or Finks upgrades. You should implement robust auditing and centralized logging, and you should go all in on continuous end-to-end, continuous deployment. Finally, you should manage vulnerabilities not at the system level or at the individual application level, but you really should think about it holistically of building base images, applying just deltas of applications, and then addressing vulnerabilities at the right level, and really cutting down the work that it takes to get to that end result of a secure environment. So, immutable systems. So the first thing is to build base images that include almost everything that you need on almost every one of your systems. You should work towards, and this is a goal, honestly, because it takes design at each system level, but you should work towards a place where those systems literally are read-only except for the data. You should implement things like CIS benchmarks, SANS checklists. They give great guidance on the type of auditing, the type of lockdown of systems that you should implement so that you don't naturally fall into the problems that you would otherwise have, and you can avoid sort of wholesale attack vectors. Finally, leveraging configuration management, standardizing all software deployments, all changes to configuration through that pipeline makes it reproducible, makes it auditable. And I think that particular point is important because in the end, a lot of the security practice comes back to auditability of the systems and just preventing, attack vectors. The next major area is what we've called Finks Upgrades here. There's lots of names for it. But ultimately, it means that you always stand up new instances. You don't upgrade them. You route traffic between the old instances to new instances. You have rich metrics that tell you whether or not the new version is working or not working, and you effect rollback immediately by swinging the traffic. In advanced cases, you can have that routing being selective. Maybe you roll a percentage of customers, or you reroute just a few customers over, and you sort of canary that new version until you're confident, and then you swing everything over. The results of this is that you sort of create this evergreen renewing of your systems. And what I mean by that is if you take the premise of building base images, you always apply the application-specific configuration on top of it, you roll your new versions out, and every time that you do a deployment of a new version, you're composing a whole new stack. Where before, in a more traditional environment, what you would do is you would slowly upgrade packages and you would accrete sort of technical debt on those systems. If you throw that all away and you talk about how the only way that we do this is build it up from the base, layer everything on top of it as the current known good, you validate that and you roll it out, every single version deployment becomes an opportunity to get value out of all of the security fixes, all of the application OS fixes, every time you do a rollout. It takes discipline. There's a spectrum of, of efforts and choices you can make along this way, but if you commit to this approach, you really can get value, not just in terms of security, but in terms of system reliability and being able to swing versions in, get a good confidence with them, and then move all the traffic over to them. And it's a good way to, if you think about it, it's a good way to actually make your systems reliable. It follows a lot of the sort of multi-AZ, multi-region patterns as well. The third major area is not terribly glamorous, but it's necessary. You should do good auditing. You should set Audit D up on your Linux systems so that it captures all of the activity on those systems. You should use the CIS benchmarks to do that Audit D configuration, and you should configure all of those logs to move very quickly off the system so that they're available, they can't be tampered with, so that they're auditable in the end. You should centralize those logs. You should have operational practices and audit practices around them, and you should do this across all of your systems. It's a not glamorous, but important aspect of doing security, doing compliance well in this environment where everything is very dynamic. The next major area is really to embrace continuous deployment by adopting a configuration management tool, by standardizing image-based building tools, by choosing, deploying sort of an environment subsystem orchestration layer that will stand up whole subsystems that'll carry out rolling upgrades. There's lots of tools out there. It doesn't matter really in particular what you choose, but you should choose a set of them that works well together so that what you get is an environment where the stand-up that you do in production is the same stand-up that you do in staging or in testing or, frankly, on your developers' desktops. One of the things that we've done in our deployments at AlertLogic is we've tried to make that available at a developer's desktop so that when they deploy whole sets of subsystems, you get monitoring, you get metrics gathering systems, it implements all of the monitoring checks that get deployed with those systems in production, and that gets rolled out in exactly the same way in a set of containers on their desktop. They can scale that up to an AWS deployment for larger scale, and then obviously go through testing and then pushing it in production. But the important thing is that it's always the same. What you want to get to is this sort of holistic view of system validation and testing, and you want to ensure that that has ingrained through it this notion of always seeking that secure configuration, always optimizing your efforts on it. So then this last thing is actually pretty simple, but it's a very important point. If you seek to build sort of from base images, you get all of the things that are used across all of your systems in that same image. And then you remediate vulnerabilities in that image. And when you roll out new versions of systems, you always build from scratch. So the next version picks up that new base image. You're not only addressing vulnerabilities, problems, security flaws that exist in the systems where you've detected them. You've fixed them everywhere because you're consistently applying a level of system configuration, software, tools that get you to that most secure position, and you're applying it every time. Ultimately, this ends up, and this is sort of the benefit, is the upside is you do less work if you approach it this way, but this approach takes a systematic effort to organize all of your rollouts, to organize the composition of all your systems. Last section I want to talk about really is, moving from sort of practices that we can have now, things that we can leverage, get value out of. I want to talk about really where we need to get to address this disparity between, sort of security tools and practice and DevOps deployment models where you're doing 10, 20 deployments a day. Maybe not everyone is doing that, but you're ultimately looking to get as many deployments as is practical to get the velocity that you're looking for, and that isn't on the order of weeks, months, or quarters. In order to do that, you need to have tools that react naturally to that type of environment, where things are changing, where during a typical week you could have tens or hundreds of different configurations of your entire system. And you need those tools, you need those techniques to be continuously interacting, integrated into that environment. So what I'm going to talk about a little bit here is sort of 3 fundamental things that need to change going forward that will give you the ability to no longer be behind, but to be sort of on point, up to the moment with the sort of security assessment of your systems and your responsiveness to those problems. And this is where. Apologize. Okay. So what I have here is sort of a demonstration of some things that we've been working on. The very first thing is to leverage sort of this end-to-end visibility that you get with Discovery APIs and with CloudTrails logs. What you see on the screen is some work that we've done in being able to sort of automatically discover the systems, to be able to show the relationships between subnets and hosts and load balancers, and to then be able to react sort of in real time to the changes that exist in those environments. What you're seeing here is just a simple selection that shows that there's a set of authoring hosts, some of which front end to a load balancer. There's some publishing hosts, which are actually in front of the authoring hosts. And then in front of that, there's DMZ and jump box. So those, this is a pretty basic deployment, but it gives you visibility in how those things are connected and how they relate to one another. What we're going to see next is an auto-scaling event that shows basically the system responding to load. So the hosts get added, they join with ELB, and then you get sort of up-to-date visibility. The second thing I want to talk about is really moving from sort of a periodic assessment into a ongoing continuous assessment. So this is the same sort of deployment, but what we've done is the tool has scanned the environment for vulnerabilities. And you can see that there's a lot of vulnerabilities that are found on various hosts in the system. They're all the little red action that goes on there. The system will, then can show you what each of those vulnerabilities are. Again, we'll look at the vulnerabilities in the sort of published servers. These are on the sort of front-end servers that are attached to the load balancer. On the authoring servers, you can see they're really on the back-end systems that are fronted by the hosts that are on the load balancer. They're not actually showing any vulnerabilities. And there's a couple of vulnerabilities that are actually on the jump hosts that are in the DMZ. So now we want to deploy updates that really fix vulnerabilities. So the first set of updates that have happened have fixed vulnerabilities from the DMZ system. The system is detected, re-scanned, and decided that those vulnerabilities no longer exist. What you need to see is that the products need to be able to react to those deployment pushes that you make in your environment. You need to be able to remediate things, have them immediately have an effect. You're not keeping spreadsheets, checking off where are the vulnerabilities, chasing people down and asking them, did you fix this, and when is that scheduled to go out? You need to turn that around, and the activity of doing developments, testing, continuous deployment just results in things being better. And in the same way, in an ongoing fashion, you will see that that technologies can also determine when new vulnerabilities exist, and they can sort of recheck all of those systems in a continuous fashion so that you're no longer scheduling this to run once a week. You're just checking the deltas, and you're getting actually the same value that you would get from doing rapid, ongoing recurring scans. We're going to clean up some vulnerabilities that are on then the internal instances. And then what we're going to do is move on to sort of the next topic, which is to protect sort of with automatic reconfiguration with security tools. So what this means is you want the system to see what's going on. You want it to react to those changes, to be able to realize what's there. And then you want the security tools to be able to scale or reconfigure to handle the changes in your environment automatically. You don't want to have to go perform a bunch of configuration. You want that to happen as sort of a natural fallout of just doing the work that you need to do and not having to manage sort of security technologies, not have to implement a bunch of processes. You want it to happen sort of as a natural outcome of just the tools that you're working with. So in this example, it's a more complex web application. What you see here is basically you see the web application firewall. You have sort of masters, workers that are front-ended to then the web workers that are actually servicing the traffic. It's a fairly simple deployment. It looks a little complicated because there's a bunch of ELBs between them, but you see the sort of natural tiers. What we're going to look at now is we're going to look at that environment scaling up, auto-scaling to demands and traffic. This is a dashboard that just shows sort of scaling up of traffic. What you'll see is that all those instances that got created because of the auto-scaling events are now discovered by the system. They're visualized on the display. And now we're scaling up actually to over 10 gigabits. So there's more WSM or web firewalls, there are more web workers that are shown, and it's actually scaled up to a fairly large deployment that's able to handle that kind of traffic. This type of natural automatic reaction to the changes in the environment is what we should be building for, what we should be looking for in our security tools and practices. We are in the early days of working on this technology, but we at Alert Logic would love to have conversations with people about this. So I sort of encourage everybody after the session to sort of come by and talk to us at our booth, All right, I'm having an AV problem. I can't get it back. Okay. Apologize. Anyway, if you could come and talk to Alert Logic at our booth at 1222. We've got some exciting technologies that we can talk about today, as well as sort of what we're working on in the future. George and the Chef guys have some pretty interesting demos where they're talking about doing you know, the sort of Finks upgrades, blue-green upgrades, and implementing those practices using Chef and their tools. So I encourage you to come by and talk to either of us. I think we have some time where, we'd be open to questions too before we're kicked out of the room and we have to go to the other sessions.